Ladies and gentlemen, welcome. This presentation was brought to you by the Visual Society of Engineers. I thank you for giving me the opportunity to share it with you and to all electrical engineering professionals working in the field. Bonding and grounding covered in the National Electrical Code of Article 250. Grounding is important for the safe operation of electrical system and eliminate hazard created by electricity. Electrical systems that are likely to be energized should provide a low impedance path to operate overcurrent protective system. Such low impedance path is considered to be the effective ground path. The single most important reason to have an effective ground path is to have electrical energy returned back to the source. The ground system shall create an effective path by making connection to earth. Electrical systems that are grounded shall be connected to earth in a manner that will limit the voltage imposed by electrical surge. Electrical surges is created by one or more of the following, such as voltage surge can caused by a faulty electrical system, a phase to case or phase to ground. It may also result from lightning strike or incoming line surge. How we establish grounding. Grounding is connected through one or more means, such as an equipment grounding conductor, a grounding electrode conductor, an equipment bonding jumper. Grounding have a way of making connection through these mechanical means, such as pressure connector, a grounding terminal, screw faster, or other listed means. Electrical grounding system in Exhibit 1 is created when we utilize the different elements that help acquire grounding by one or more of these methods, such as the use of bonding jumpers, grounded electrode conductor, grounded rod, concrete encasement electrodes, etc. All of these components help to form the grounding system when we tie them in the building framework. The diagram illustrates how an effective grounding path is created when we use an equipment grounding conductor. The conductor is bonded at both ends of the boxes and then feed through the conduit and pipes to create a low impedance path. Anywhere along the system a fault current is created, it will use the equipment grounding conductor to return back to its source. Now, what's the primary reason for grounding? The primary reason is as such to create a safe system of operation of electrical equipment, to reduce the effect of lightning strike, to prevent a shocking hazard due to energized metal surface not intended to carry electricity, and to isolate a faulty circuit that can lead to an electrical fire. And conductor will burn so long as there is no effective ground path to the source to open a breaker. The proper grounding system helps to safeguard person operating electrical equipment of conductive surfaces. When a faulty condition is created, the grounded conductor serves the purpose of returning the faulty current to the source to isolate the breaker, hence protecting the person operating the equipment. Bonding. Non-current carrying conductive material must be bonded to an electrical equipment and enclosed to the electrical supply source, such if energized will take the fault current back to the supply. Example of a non-current carrying metal surface that likely to be energized is electrical equipment, a panel enclosure, electrical boxes, handrail, and also metal floor grating. Bonding serves the purpose of removing electrical fault current from all metallic surface as illustrated in Exhibit 4, where water pipes, water heater, meter boxes, panel is bonded together before finally taken to a grounding electrode conductor or grounding rod. Objectionable current is common fault on grounded system. Objectionable current is caused by an unintentional or unintentional current imposed on the grounding system. Objectionable current defeats the purpose of a grounded system. What causes objectionable current on ground system? Objectionable current is created when there is an improper wired electrical system. It may cause by bad or poor arrangement of surge arresters. Objectionable current is created also from improper connection of the grounded system at the source. Objectionable current may result from neutral to case fault, a faulty surge protective device, or when we have multiple grounding connections. In Exhibit 5, a neutral to case connection creates an objectionable current that enters the grounded system. When high enough can operate overcurrent protective device, but when go undetected remain on the grounding system indefinitely before imposing an electrical hazard. Thanks for your interest in this presentation and stay tuned for more. Please go and register to our website at www.vigilantsocietyofengineers.mn.co for more information on grounding and bonding.